This video should provide you with everything you need to know for the reason why we use 92¼ wall framing studs or 7' 8¼ wall framing studs for walls that are going to be 8 foot tall. Or should I say for a wall that is going to have an 8 3/4" overall height. And by the time you're usually done framing, it's about 8'1" tall. And the reason why you're not just going to grab 8-foot wall framing studs to build a wall for your building is usually going to have something to do with the drywall and the exterior siding or shear panel, and whether or not these materials will work effectively for your project. So the first thing I want to point out is that if you are using 1/2 inch thick drywall for the ceiling, then there's a good chance this is going to take 1/2 inch out of the overall height of our wall framing. Now bringing us to about 8'1¼ inches in between the bottom of the ceiling drywall and the top of our floor, or in this case, the top of our stem wall. So again, the overall wall framing height is going to be around 8'3/4 inches. And we've just subtract 1/2 inch from that overall distance. And then when we install 2 sheets of drywall that are 4 foot wide, we're usually going to end up with 1/4 inch at the bottom. And of course, this won't be a big deal and won't always be 1/4 inch. This gap might be larger or smaller. So again, the 92¼ inch wall framing studs allow us to use 2 4 foot wide pieces of drywall installed horizontally or 1 4x8 piece of drywall installed vertically. But that's not going to be the case if we use 8 foot tall wall framing studs. This is going to leave a gap at the bottom of the drywall. And I'm not about to suggest this is a big deal. To an engineer, this might be a big deal, who is planning on using the drywall for some type of shear value and doesn't want to see a small piece of drywall installed at the bottom or in the middle or at the top. And let's not forget that you can usually purchase different materials. You can purchase wider drywall and longer drywall if needed, along with exterior shear panel if you need it for your wall framing. So for example, I could always buy a 9 foot or a 10 foot tall piece of shear panel that is going to be 4 foot wide to solve my problem if I need that. However, it's going to cost more money. So this is the reason why we don't use 8 foot long wall framing studs, and instead we use 92¼ to create a wall that's going to be about 8 foot tall. In this video, I will provide you with roof framing suggestions, no wall framing or any other structural suggestions, just a few ways that you can build a larger or wider building, especially a garage. I've been getting a lot of requests for this video. And if you do need more information on how to build a larger building, feel free to let us know in the comment area. And I might make a video series on how to build a variety of different sized garages or buildings with conventionally framed roof rafters that would not have engineered trusses in it. So what we have here is a 30-foot wide building with 2x6 rafter ties that lap in the middle. And the rafter size is irrelevant here. You're going to have to check with your span charts or your engineers or local building authorities and contractors to get that information. And in reality, a 30-foot building can probably be built with larger roof rafters than 2x8 or 2x6. And for those of you wondering how I'm getting the roof rafters to line up at the top and the rafter ties to connect to the same side, I'm just simply angling the rafter ties. And that's not going to be difficult to do in this long span. And of course, the rafter ties will lap, and I believe a 4-foot lap would be sufficient with about 10 16D nails on each side. And the rafter tie will be held up by a 2x support, 2x4 that will nail into the ridge or the roof rafter. And you can see here where I rotated this one 90 degrees from this one. And we'll let you choose which one is going to work better for you. Because in a situation like this, we're going to be nailing this support brace into the ridge and then end nailing this 2x4 rafter tie into the brace, or toe nailing the brace into the rafter tie. And this is another question I get a lot. A lot of people think that this brace right here is helping to support the ridge and is only used to hold up the rafter tie to prevent the rafter tie from sagging down, especially in longer spans. And if that doesn't make sense, you need a little more information on that, let us know in the comment area, along with any other questions you will have about this particular framing. And of course, your collar ties, a 2x4 will do, a 1x6 I believe will do. And the collar ties, along with the rafter ties, cannot be spaced more than 48 inches on center. However, you would need to check with your local building codes to verify that information. And in our next example, what most of you have been waiting for, how to frame a conventionally framed roof using construction standard lumber and no engineered trusses in wider buildings. So here we have a 40-foot wide building, and we're simply going to install structural support beams in the middle of the rafters, the middle of the span here, middle of the span over here. And sometimes we will need to install a structural ridge beam that will be supported in the same way these beams are supported, with a post transferring the weight down to the building foundation, which might require a concrete pad here, something larger than your original footing. And the rafters will simply lap and fasten together with 16D nails. And I'm guessing you would use about 10 nails here. And no, 10 is not the magic number. Another thing you would need to check with your local building authorities on. And this realistically is the key to making wider buildings with conventional lumber. By reducing the overall span, cutting it in half sometimes, or even thirds, depending upon the width of the building and the materials used. And sometimes the rafter ties can be supported by the roof rafters using support braces like these. And for those of you who have been paying attention, you're probably wondering why we don't need rafter ties to go from one side of the building to the other. That's because we're using the structural beams. The structural beams will function in a way, when built correctly, to prevent the walls from spreading out, which is the main reason why we're going to be installing rafter ties. And if you install a ridge beam, you might not be required to install rafter ties. However, you might be required to install additional bracing to prevent the roof from moving in a variety of different directions. Last on our list, let's take a look at a 60-foot long building, and you guessed it, all we need to do is add a few more structural support beams, along with some building hardware. I'm not going to be providing you with all the building hardware you're going to need in this plan. However, straps will be required to connect wall framing top plates together. And I do have more information on a variety of different things at our website if you need to look at it, along with strapping, structural bracing, collar ties, rafter ties, you name it. Head to the website, check out the roof framing section. And in the longer buildings, you will have rafters that will again connect to the other rafters and to the structural beams. And you will probably need some blocking in between the roof rafters. In this video, we will take a look at the second-story wall framing for our two-story house with the wraparound porch. Now in this video, I'm going to go ahead and leave the floor framing in, get about halfway through the video, and then remove the floor framing, the wall framing below, and the foundation to provide you with a better view of the wall framing. And almost every wall in the video will have another wall that will be built exactly the same. And two of those walls will be this one and this one, where they will both be built on top of a beam with 2x6 wall framing studs and a ridge post, a post that will carry the load from the roof framing above down to this beam here, and then of course down through some posts to the building foundation. And of course these two walls here will be built exactly the same also, with a window in the center and a 2x4 to help us support the ridge. And in case you're wondering why we don't have a ridge beam here, that's because we're going to be getting the structural support from the bottom of the roof rafters. However, I'm not about to suggest that you wouldn't need a ridge beam here. So contact local building authorities or engineers in your area for clarification before building a project exactly like this. And these walls here again will be the same proportion or the same size and will be supporting the bottom of the roof rafters. And that's the reason why this part of the wall continues through to the outside and not butt up against this wall here. However, I'm not about to suggest that you couldn't have that rake wall go all the way down. And the simple fact that this building is built in sections that have the same proportion and similar measurements will allow you to calculate the measurements for some of these walls a little easier than it would if they were different measurements and different sizes. And this wall right here will not have a hinge point because we are going to have a ceiling joist up against it. However, this is a wall that you could balloon frame and have full length wall framing studs. And I believe this is the only section in the house where that could happen. And the rafters for this section will be sitting on top of this wall framing. Again, we have the same situation here where we're running this wall through to the end so that the rafters can sit on top of it. Next up, let's go ahead and set our roof ridge. We will need a ridge here because we're not going to have the same structural support that we're going to have down here or in this room or this room. Next up, let's go ahead and take a look at the little dormer pop-outs that we're going to have here. And this will be a small section and create some tiny rooms, but definitely add to the nice design of the building. And another thing you should keep in mind that when you do small things like this with a lot of detail, it's going to cost a lot more money on your project. I would imagine if you left both of these dormers out and then just brought the roof down or even set the dormers up a little further, you could definitely reduce the cost of the project. However, how much, I wouldn't be able to provide you with that information, or whether or not it would actually be worth it to do because of the design. A view of how the corner here will connect together. Again, the rake wall is coming down, butting up against the wall that the roof rafters will be sitting on. And of course, without the lower section in the way, some of this stuff is going to be a little easier to see. And of course, that would be my learning curve there. As I do more of this stuff, I can get a better idea of just how confusing it is to see some of this stuff when some of the other framing components are actually in the way. And some of these sections might be a little easier to build after the roof is built. I don't expect you to build this section right here before the roof framing has been installed, but that doesn't mean you can't extend the top plates out a little bit so that they can be cut off later. Main section again, and a view of how this wall is coming out. This one here is butting up against it. And again, there is a beam underneath this wall to support it. And we have a header going over the wall here because the walls aren't very high. I want to say they're about 7 feet, and a regular door might not fit in here. You might need a custom door made for that area, or you would need to raise the wall framing. And of course, the wall studs that will be sitting on top of the framing plate below. The ridge beam, a better view of it there. And how it's going to be supported by a post so that we don't need to install a monster-sized beam there. And of course, the load from the ridge will transfer straight through and not through the headers. So if we had a header that went all the way across and then a post sitting on top, then the weight would transfer around and not straight through. And of course, that could provide you with another design option also. And let's not forget that you might need a ridge beam coming off of both of these points here to the wall here, and then sit on top of a post that would be located in that wall to transfer the load down through the floor framing to the foundation. And with that said, let's go ahead and wrap this video up. Here is another video that is inspired by some of the videos that I have seen on the internet, one especially. And even though I will not be providing you with any details about the video, it has inspired me to provide you, the viewer, with something you might not want to do. And that would be to use individual footings or small blocks, bricks, you name it, underneath your stringers. However, I would also like to say that I do understand why someone might do this, especially if your ground freezes in the wintertime and causes frost heaving or forces sections of your concrete footings to rise or raise above the ground. However, if I was going to build something like this, I still don't think I would use small individual footings that don't go into the ground deep enough. And I think the project I saw, it looked like they poured the footings after they set the stair stringers, but I'm not sure. Here we have a set of stairs where everything is nice and straight. And then maybe in a few years, you end up with some of the stringers and the footings either sinking into the ground or raising above it, creating a situation where you no longer have, in my opinion, a safe set of stairs. And this problem is going to get worse the further you space the stringers apart. So here we have them spaced about 16 inches on center. Here they're spaced 24 inches on center. And depending upon the size of the footing, you could end up with them tilting to one side as the soil erodes from underneath one side of the footing. However, I can't end the video without providing you with some type of hope, and that would be if you're going to use a 2x, maybe a 2x6 or a 2x8 for your risers, and you firmly attach them to your stair stringers, then these can actually act as structural supports. And even if you do end up with a couple of the footings sinking into the soil, or rising, the stringers could actually provide you with enough structural support to prevent the stairway from deforming too much. So keep that in mind if you are going to just simply place a few blocks or pavers underneath your stair stringers because you're trying to save a few dollars, or you're dealing with another problem that I didn't mention in this video. And that problem might actually be the fact that you just don't have enough money. You need to save a few dollars here and there. Then I get it. Just be prepared for problems in the future. And maybe a helpful solution to that would be to use screws for everything so that you can unscrew some of the treads and risers so that you can access these areas for easier repairs in the future. In this video, I will provide you with an example of something that could create a headroom problem if you have a set of stairs above another set of stairs and you're already dealing with something that is at the minimum or close to the minimum headroom height allowed by your local building codes. And this is actually something that was brought to my attention by someone who was removing and replacing a stairway above another stairway that went into a basement. And it's really not too difficult to understand how you could affect the headroom height. Let's go ahead and provide you with an example of what the headroom height would be for this stairway. And that's usually going to be a vertical measurement from the front of the stair treads, going from the farthest projection forward off the front of the stair nosing or stair step all the way to the top of the ceiling. or in this case, the bottom of the stairway. So let's pretend like this measurement here, this area represents the minimum stair headroom height for a stairway. And if our new stairway is going to be moved forward, we're actually going to increase the height of the headroom. And in this example, we moved it backwards, or in this direction here, and reducing the height of our headroom clearance. However, if we leave this one in its current spot and move this one in this direction, we're going to have more headroom. And the opposite would hold true if we move the lower stairway forward in this direction. However, this is not what originally inspired this video, because the individual was going to build a stairway that was going to be wider. And as you can see here in this example, this would reduce the headroom height. And in our example here, I increased this distance by 4 inches, and it's going to affect our headroom height by 5 inches. And I would imagine this is going to be a big problem because most people are going to be replacing the old housed stair stringer type stairways. And I'm guessing they built millions of these types of stairways that went into your basement, and millions more that were above the stairway in the basement. Next up, let's go ahead and take a look at what you're probably going to be dealing with. Smaller steps and taller risers. And you're probably not going to have the room to make them longer. However, if you do, and this seems to be a big problem, I get a lot of viewers requesting information on this. And I've already made quite a few videos explaining it a variety of different ways. This is just another one that I hope will make a little more sense, because most of the time, the individuals who are asking me how to solve this problem want to install a longer stairway, a stairway with longer steps and shorter risers. And hopefully by now you know exactly what I'm going to say next. We're going to end up with a headroom problem here unless you replace the upper stairway and create the same stairway or something that will provide you with a safe headroom ceiling height for your project. So again, if we move the stairways in different directions, or if we make them longer or shorter, or make them thicker and fatter, we could end up reducing our headroom ceiling height for the stairway, which in turn would create building code problems and make the stairway difficult for taller people to walk up and down. This is probably the last video in our series on the house with the wraparound porch, and I'm going to cut it short because it didn't seem like there was that much interest in it. So let's go ahead and get started by removing some of the stuff that will make my video turn a little faster and avoid annoying color changes. And of course that happens, I think, when I get too much stuff in some of these videos. I mean, sometimes I have all the nails for the hangers and then all of the rebar, you name it, and it changes colors while I'm going from scene to scene. And in some of the examples, I'm going to focus in on one part of the house, where we have this roof here built pretty much the same as the one in the front. So I'm not going to go around every single part of the building when I think you can get a pretty good idea what the front porch is going to look like by looking at the back one, or what each side of the house will look like. And again, this wall right here is going to be the same as the one on the other side. The front porch is going to be a little longer than the back, and this side is going to be a little different than the other side. But for the most part, this gable end and this gable end, this gable end, this gable end, this dormer and this dormer are going to be the same, along with the same measurements. Let's go ahead and remove the fascia board and then come in on the front corner of the porch here. And in this model, I spaced all of the rafters 16 inches on center and tried to make it work out for the plywood. So I kind of went 16 inches on center all the way through in both directions if I could. Zoom in on this part of the house where we're going to have a full-length rafter and a partial rafter that's going to nail into the wall framing along with our ledger here. This will not be a ridge since it is going to be nailing into a wall. And we are going to be using 2 boards instead of 1 long board for our ridge here, along with shaped blocks over the exterior wall framing. And this building will have a flat soffit all the way around. And you could always install some backing here. I didn't because I wanted to show you something I've done before, and that would be to build this dormer roof over this roof. I'm going to install my sheathing here and then nail the roof sheathing to the bottom of these boards here. I've done that before and nobody's ever had a problem with it. However, if that's not going to work for you, don't do it, of course. And then this roof here will build over this roof. You'll put the roof sheathing on this first and then build this section of the roof over it, along with your fill rafters, common rafters here. And again, we have 2 boards creating our roof ridge. And I went ahead and left these blocks a little lower, but you're probably going to need perimeter nailing. These blocks will need to go all the way up to the ridge. However, I have seen them lowered before like this when installing ridge vents, something that will allow the air to circulate out of the attic or into the attic through a ventilated ridge that might be made out of metal. I don't think I've ever seen them made out of plastic. And of course, our rafters will lap here, and since we are working with a 45-degree angle here, the ends of these rafters will be square on each side, which might make it a little easier to cut the roof rafters. And of course, our mid-span blocks that we have here usually go in the middle of the span of the common rafter. And of course, our little wacky roof. When I was designing the project, I really didn't understand what I was going to be getting into here. But you can see here where this is going to need a little creative adjustment for the roof sheathing, along with the fascia board. And of course, this section of the roof here took me a little while to design. And this section of the roof is going to sit on top of the lower section, or the porch roof. And be prepared to spend a little bit of time working on this section of the roof if you build a house like this, to get everything to plane in nice and flat all the way around. And of course, the porch rafters will be connecting to the roof rafters here that will be sitting on top of a wall, a short wall. And I would imagine after you finish building something like this, you could consider yourself to be a roof framer. And the porch is going to be a little bit longer in the back, might require larger rafters, and you might need to install larger hips or double up the hips or add some type of structural supports in the areas where the hips are going to be sitting over some type of load-bearing walls. Let's go ahead and zoom in on the upper connection for the hip. It's going to be sitting on top of the wall framing plates, and the roof rafters will be sitting on top of our stem wall or short wall here. And the porch rafters that are not going to be connecting to the hip will be lapping and connecting to the roof rafters. And in this section here, they will be sitting on top of the wall framing also. Take a look at the ceiling backing there. And the ceiling backing is going to go all the way around the rake wall here. Next up, let's go ahead and take a look at the dormer. We're going to need a doubler or a beam here, along with a doubler on each side of the supporting beam. This beam is going to be supporting a section of the dormer and might require some type of structural engineering. Keep in mind that I'm not a structural engineer, and before building something like this, you should contact somebody to provide you with the correct lumber sizes for your area. Another view of the lower connection there for the rafters. A view of the porch framing here. Ceiling joist here, right here, and then our porch rafters here going up to the ledger. Ledger is going to attach to the wall framing. A view of our double windows there. And I'm sure I drew my ceiling backing in there somewhere. It just disappeared. Let's go ahead and add our fascia board and then zoom in on a couple of sections where the fascia board goes over the roof sheathing. You're going to need to have a gap here to allow for the roof shingles to slide underneath the fascia board. If you don't, the roofer won't be happy. And then a view of the corner here. You've got to make sure that wherever you need the roof shingles to go under, that you have enough space for them. An example of how the porch roof is going to die into the upper roof. And I think this roof here is a 2 and 12. Don't quote me on that. And at the other side, again, we have the gap for the roof shingles, how our wacky section here is going to die in. And let's go ahead and wrap this video up with 2 more pictures, and that is it. A nice upper view of the roof with a longer roof in the back, shorter one in the front. And if you want to save some money, get rid of this thing right here and get rid of the 2 dormers here. In this video, I will provide you with a couple of things to consider before repairing any cracks in your drywall. And the reason why I'm suggesting this is that I've seen a lot of videos where someone shows you how to fix a crack without actually solving the problem. So there's a good chance the crack will come back again. So let's go ahead and take a look at the perfect building foundation, perfect wall framing, drywall, no problems. And then next we'll take a look at the biggest problem, and this is going to usually have something to do with movement in the building, whether it's the framing or the foundation. And most of the time that movement is going to come from the building foundation, either raising or sinking. So we can look at this example either way, either this section here raised or this one here lowered. And if you do have foundation movement like this, then there's a good chance that a section of the wall will also move, and this movement here will often create enough pressure, enough stress on the drywall or plaster to cause it to crack. And this is probably obvious, but I got to throw it out there. And that would be that the larger the crack you have in your drywall will probably suggest that you have a larger problem with the rest of the house, either the wall framing or the building foundation. And building foundation issues are usually caused from soil erosion, water leaks causing soil erosion, frost heaving, poor soil compaction when grading on newer homes, along with a few other reasons on my list: fluctuations in temperature and or humidity, vacant buildings. These would be buildings that might be left for a long period of time without any type of climate control like air conditioning and heating. Then we have the notorious earthquakes or strong winds, something that can actually create stress or move your building enough to cause something to crack either on the inside or the outside. Next up on the list, you might be dealing with the wrong products used or even bad products. Some of these products do have expiration dates on them. And then we have some materials that need to be mixed on the job site. And if these products weren't mixed correctly, you could end up with drywall cracking along the joints where each piece of drywall butts up against another one. Next up on the list, incorrect assembly of drywall and or taping and finishing, along with incorrect nail or screw sizes, on-center spacing, and even whether or not the screws or nails were installed at the correct depth. Next up on the list, and another biggie, would be any type of wood framing damage that might be caused from wood rot or termites. And last on the list, we have roof truss uplift. And I do have a few other videos on that also. I will try to put a link to that in the video description area. In this video, I will provide you with the most common roof pitch, and I would say this is probably all over the world. I cannot say for a fact that this is going to be the most common roof pitch in your area, but according to some of the research I've done, a 4-12 roof pitch is the most common. And out here in Southern California, I can vouch for that. Here's the winner right here, a 4-12 roof pitch. And I can say for a fact that I've built more homes with this roof pitch than any other home, period, hands down. And I've seen them all over the place, even in areas where it snows. However, even though what I'm telling you is true in my case, it might not be the case in your area, because the climate is usually the key factor that determines the roof pitch in most areas. For example, in desert climates, you can see roofs with lower pitches all over the place. However, that is not going to work in areas where it snows a lot. And this is actually something I was trying to drive home to one of our viewers who was building a home addition and using a low sloping roof. It looked like it was about 2 and 12. So keep that in mind. The most common roof pitch in your area might not be a 4 and 12 roof pitch. Here is another video in our series on building different types of A-frame homes. And in this one here, we will build a roof that will shed a little bit of the snow easier than in the previous example. And there were a few comments in the previous example that suggested what a horrible design it was. And I'm not going to argue with that. I'm just trying to provide different ideas in the video for people who might be building something like this. So let's go ahead and get started and take a look at our back wall. We are going to have a 2x4 wall in the back, a 2x6 wall in the front. And we're also going to extend the wall to sit on top of the roof sheathing. On the 24 and 12 pitch roof on the main house, we're going to have a 12 and 12 pitch on the garage. And again, a 2x6 wall here. That's so that we can put a larger beam in for the garage door header. And if you notice, we're going to have double trimmers here. You might even do better off with a post, maybe a 4x6. And don't bother asking what size lumber I'm using in the video because I can't provide you with the lumber sizes you're going to need in your area. If you've watched enough of my videos, you know that. And you can always make the back wall a 2x6 if that's something you need to do. And in this video, I'm not going to have a door coming from the main unit here, the A-frame, into the garage, and part of the reason for that is the drop that I have here. You can see the difference in the floor, and it looks like it's a little bit over a foot. That's going to create a problem for our door opening. However, I'm not about to suggest that you can't modify it to create a door opening from this side of the building into the garage. Next up, let's go ahead and install our rafter ties. If you want to install ceiling joist, you can. We're going to use rafter ties here going in this direction, and then some ties going in this direction. We're actually going to connect it to the rafters in the A-frame part of the home and run it all the way across to connect it to the exterior wall here to give it some support. We don't want the wall moving, and these braces will help with that. And of course, I have two of them flat, one here flat, and one on edge to provide you with a different example there of how you might connect them, along with how they might connect to the rafter ties. And here I had to attach a couple of blocks so that I could connect the brace that will be thoroughly nailed to the other support brace that will be sitting on top of the rafter ties. And you should attach all of this stuff together. End nail the flat board to the rafter tie, toe nail this board to the rafter tie, and again you can just end nail, drive some nails down through the 2x4 into the rafter tie, and then drive some nails through this 2x4 into this 2x4, and then some nails to connect the rafter here to the brace. And hopefully you don't need more information on that. I don't put a lot of nailing information in the videos. They're kind of more meant to provide you with design ideas. And I'm kind of going on the fact that you already know how to connect this stuff together. If you don't, I do have plenty of videos showing you how to connect everything together. And you can find those on our website. Let's go ahead and add our rafters. Again, a 12 and 12 roof pitch. And each one of the rafter ties will connect at 4 foot on center to a rafter so that we can get a nice connection all the way through here. Rafter ties are 4 foot on center. Our rafters are 16 inches on center. So every third rafter will connect to a rafter tie. And the rafter ties are used to prevent the walls from spreading and the ridge from sagging. And again, I do have more information on that at our websites. Let's go ahead and put our fill in. Zoom into the bottom here to give you an idea how the rafters are going to be sitting on top of this wall here. And I went ahead and put my stud underneath the rafter since I'm going to have a single plate here. If you want to add another plate, then this wall stud doesn't need to be directly underneath the rafter. Next up, let's go ahead and take a look at the ridge. And I went ahead and had the ridge sit on top of our support boards here. You can always have the ridge sit on top of the sheathing, but I went ahead and did it so that I could show you how these support boards basically go up and kind of form a peak here, where if I was to run this through and have it sit on top of the sheathing, I just wouldn't have this. And I would imagine some engineers would rather have the ridge sit directly on top of these support boards instead of the roof sheathing, especially if the ridge won't be sitting on top of a rafter. Next up, let's go ahead and head over to the other side, give you an idea how the sheathing is going to kind of connect into here, run straight on through. And since this is a 45-degree angle, you could always shape the top of the ridge. That wouldn't be too difficult to do with a 45-degree angle. And of course, how the rafters will blend in, create a flat surface through the fill area. And our blocks, we're going to shape the top of the blocks. Again, not difficult to do with a 45-degree angle. However, it would be difficult to do for steeper roof pitches than a 12 and 12. And of course, our wall here, this will be our firewall. We're going to need to have a firewall to separate the garage from the living area. And if you're going to put a door from the garage into the living area, you're going to need a fire-rated door also. And of course, a better view of how we're going to use these boards here to connect to the 2x4 wall framing studs to provide us with some more strength to prevent the wall from moving in and out. And you can always space these braces closer together. I have them at 4 foot on center. You could use 32 inches on center to make it a little stronger. Next up, let's go ahead and add our fascia board and take a look at the bottom here. And I want to kind of give you an idea if you're going to install a soffit at the bottom and the soffit's going to come all the way across here, you're going to end up with kind of a different section here. And there are a variety of different ways to finish that. I can go ahead and provide you with some of them. Just let me know if you need more information on that in the comment area. And of course, our lookouts are going to be spaced 32 inches on center, and our collar ties are going to be spaced 48 inches on center. And try to line the collar ties up if you can with the rafter ties. And we're going to move the collar tie to the other side so that we can build our wall here. So instead of having it on the right side, we're going to put it on the left side so that it doesn't interfere with our drywall. Otherwise, we would have to drywall around it. And I don't even know if you'd really need a collar tie on this one because we do have the wall. A back view of this area here. And let's go ahead and take a look at the gap between the bottom of the fascia board and the sheathing. This will allow us to install roofing materials underneath this section of the roof. And this might require you to leave some of the sheathing off so that the roofer can install the roofing materials underneath this area here. It's going to be a little more difficult to do if you have the sheathing attached. A lot of times we'll just leave a board. We'll have a piece of the sheathing that might be this big here, cut separately so that the roofer can remove this section, install their roofing, and then reattach the sheathing, nail it off, and then install their new roofing materials over this section. And I don't know if I have a video on that. Go ahead and take a look at the other fascia board corner. The blocks and how they're going to attach to the rafter tie. You could always run the block past and have the rafter tie sit behind the block if you're looking for a different type of assembly method. And of course, our shaped fascia board. And we're going to have to do some notching here to make this side here blend in with this side here. Going to have to look something like this. Next up, let's add the roof sheathing and start wrapping the video up here. Roof sheathing, not too exciting. We've seen it before. And for those of you wondering why I didn't have a full sheet here, I was about 3 or 4 inches short at the top. Or in other words, if I used a 4 foot wide piece of plywood or OSB here, I would have needed to attach a 3-inch piece to the top of that. So for example, instead of having 48 inches here, I had about 52 inches. And if your engineer does not allow for something like that, for example, if they have a 2 foot minimum width, then you're going to need to do something like this here and waste a little bit of roof sheathing. In this video, I want to talk about the difference between a repair that might not require a building permit and remodeling or modifying the staircase. Changing the design sometimes will require a building permit, and recarpeting or replacing some or all of the materials back to its original condition might not require a building permit. However, and this is the key here, if you really want to know whether or not you need a building permit for your next project, will be to actually go down to your local building department. I will not be able to provide you with an absolute yes or an absolute no as to whether or not you can replace some or all of the lumber and other materials to rebuild a stairway, because sometimes the building department is going to want you to update the stairway to meet local building codes. Now, as far as simply replacing rotted lumber or other damaged materials, you're probably not going to need a building permit. This is a repair and fall into the category of maintenance. And most of the time, maintenance, like painting, will not require a building permit. And this provides us with an excellent example of something I think the building department would want updated. And that would be if the spacing between the balusters is over 4 inches, or the height of the guard railing or hand railing does not meet current building codes. And I can tell you that this guardrail right here, which probably also has a grippable handrail on top, will probably need to be updated. And you as a property owner will probably want it updated also. And here we have another situation where the stairway might require a building permit, because almost all of this stairway will need to be rebuilt to meet local building codes. And here's a good example of changing the design of the stairway. Here we have a straight stairway that is going to be modified by rebuilding the lower section and turning it into a winder type stairway. And this modification is usually going to require a building permit. In this video, I want to talk about using heavy-duty screws to attach your treads and risers to the construction standard lumber you're going to be using for your stair stringers. And I used to use 16 D nails for 1 1/8" treads, or I would use a 7D or an 8D hot dipped or ring shank nail for 3/4 inch or 5/8 OSB or plywood. And of course I used adhesive for the treads only. I never used adhesive for the risers, and I for sure as heck didn't use adhesive with heavy duty screws or larger nails because I thought they were going to work better. And the reason for that is because larger nails or screws can split the lumber easier. However, pre-drilling the holes for your screws and even larger nails might be the solution to this problem. But I don't think you need to use 4-inch long screws that are 1/4 inch to 3/8 of an inch wide. And another reason for that would be to eliminate the screws touching each other. As you can see here, if I was to screw a long screw in down this way and then one this way, there's a very good chance I would end up with something like this at one point. And I'm not about to suggest it won't push the screw over, because it can if it doesn't hit the screw dead center. And if that happens, there's a good chance there's going to be enough pressure on the lumber, whether it's going to be on the grain of the lumber or in another area that might create a weak spot. And even though I exaggerated this right here, this is basically what I'm talking about. You could end up splitting the lumber. I've done it before with larger nails. And once this happens, it doesn't take a rocket scientist to figure out you've just created a weak stair stringer. And here's an example of the screw being off a little bit and going off to this side of this screw here. And once that happens, there's a very good chance you're going to break something. And another thing that can happen, and I've had this happen with nails also, is that when I go to nail my riser on, I could actually split the tip off of the stair stringer. I've done this at least 100 times. And to fix it, I would just simply pull the nail out, put some glue on this, stick it back, lower my nail, and then move this nail over here to attach the tread to the stringer. And this becomes a higher probability as the lumber dries out or you're dealing with kiln dried lumber, something that doesn't have much moisture in it. And I'm not about to suggest that you buy lumber with excess of moisture in it, because that lumber can shrink and create additional problems for your stairway. And I get it, people don't want to use nails because they don't want to deal with their stair squeaking. However, I don't see a need to use these ridiculously large screws without pre-drilling the holes for them, along with making sure that they don't hit each other. Because even if you have pre-drilled your holes in the wrong spot and you end up with a screw putting pressure on the other screw as it's screwing its way into the lumber and putting more pressure on this section of the lumber, good chance you're going to end up with something breaking. And another idea, of course, would be to use wider lumber, maybe some 4x12s or 3x12s. And again, I don't know how heavy duty of a stairway you're trying to build, so I won't really be able to give you advice on which fasteners to use other than those I've already suggested in the video. And I would also like to thank one of my fellow YouTube channels for inspiring this video, because that's exactly what happened to them while they were building what they claim to be an extremely heavy-duty stairway with heavy-duty screws. Here is the second video in our series for building an A-frame house, and this one is going to have 2x6 tongue and groove for the roof sheathing and the floor sheathing. And we're not going to have any fascia board on the side. So let's go ahead and zoom in on this, give you an idea of what the inside might look like. Again, we're going to have collar ties. And we're going to use beams for our roof rafters that are going to be spaced 4 foot on center. And this is the way I remember them building A-frames a long time ago. It would have 2x6 tongue and groove for the flooring and the roof roof rafters would sit on top of the floor beams or directly on top of the concrete footings, instead of sitting on top of a wall framing plate and the floor sheathing, as I showed you in the previous video. And since it's not going to look like this, let's just go ahead and remove some of this stuff and provide you with a view from above, where we are going to have 4x8 floor beams. And these beams will be spaced 48 inches on center. And we can do that as long as we're using the 2x6 tongue and groove floor sheathing. And something else you will need to do a little different will be to move the center footing back on both sides, unless you're going to be covering it up by building a deck or a landing at each end of the building. Next up, let's go ahead and add the roof rafters. And this design will have blocks in between the rafters and a beam underneath them. And the beam really isn't going to be a supporting beam. We really don't need a ridge beam for this design. However, we are going to add some support posts underneath the beam to make this building a little stronger. Now, a couple of you pointed out in the previous video that it would be difficult to assemble the ridge framing. And doing it this way might be a little easier because you could always figure out the length of each one of the roof rafters along with the floor beams and assemble everything together and then stand it up in one section. Or assemble the two rafters together at the top and even install the collar tie if you need to on the floor and then stand that up into place if that will work better for you also. Now, if you need a little more information on that, let us know in the comment area and I will walk you through the entire process of how I might assemble something like this. And as you notice, we're going to have a couple of braces here. You're going to need to plumb up this section of the building and brace it off at the sides. We're not going to worry about this right now because we could always adjust that a little later. And you can always change the bottom design of the rafter if you want to add some fascia board. And you can see where the roof rafter beam is now sitting on top of the floor beam. Let's go ahead and take a look at the other side. And you can use whatever you want to here, nails, lag screws, and even other types of building hardware to assemble this, like a strap in the middle. And the strap might not be necessary, again, because of the way the building is designed. And I'll go into that in more detail if you need that in another video. And I think the most common method you're going to use will be to bolt this together. However, I won't be able to provide you with the types of bolts or the amount of bolts that you're going to need for your project. Let's go ahead and zoom in on the bracing here. We can simply nail a block to the rafter and then nail our bracing to that block. And you could always extend the blocks up a little bit like we've done here. Otherwise, you might need to shape the top of the brace. And then we're just using a stake that we've driven into the ground. And we can attach the stake to the brace with some screws or nails also. And I think what I would do in a situation like this would be to assemble one section to create a pattern I'm going to repeat to assemble the rest of the building. And this would allow me to double check the end here to make sure that the beams are going to be the correct length where the block will die into the corner here. And that will make a little more sense once we go through a little bit more of the video. And after we have the first section braced off, we can go ahead and install our next section. And to stabilize everything, we're just simply going to use a scrap of lumber or a long 1x4 or 2x4. And you can put one of these on both sides if that's going to work better for you. And we can simply use nails or screws to position the rafters in the correct location. And it wouldn't be a bad idea to grab the rafter and kind of shake it a little bit to make sure that it isn't going to fall down, because you can always install additional bracing. And this would be one of those situations where it's going to be better to install additional bracing before continuing on with the assembly if you're not 100% sure it's currently strong enough. And again, that might be a topic for another video. Let us know if you need more information on that also. So not too difficult. We're just simply going to continue on with our bracing and our rafters, one section at a time until we get to the end of the building. And then we're going to double check everything and make sure that this side is plumb also. And the bracing is going to need to be removed after you've installed the roof sheathing up to the point where this bracing will need to be removed. You don't need to remove it before you install the roof sheathing. Just remove it after you've installed the sheathing up from the bottom or from the top to where it's going to have to be removed before you can finish with the roof sheathing. Next up, let's go ahead and take a look at the floor blocking. You can see here where we have a row of 2x8 blocks centered on the beam going right down the middle. And you could always install 4x8 blocks there if you're looking for a little more support. And the reason why we need to have the beams stop at a particular point, maybe 1.5 inches from this point here. And we could always shape the end of the block here if we wanted to. And like I said, hopefully that makes a little more sense once you look at this section of the construction. And we will need a block. I don't think you need to get crazy here. We don't need to use a lot of building hardware here. I think you could simply nail the block to the roof rafter. And don't forget, you're going to have a bolt or two coming through here, meaning that you're probably going to have to notch some holes out of the block here, or lower the bolts so you can use a 2x4 or even a 2x2 so that the bolts aren't in the way of your framing. After this, we are going to install our floor sheathing, again 2x6 tongue and groove, and you can shape the end of the block here so that you can get some nailing from the roof sheathing into the floor sheathing here. That would be a nice transfer. You're going to nail the floor sheathing into this block and then the roof sheathing into the floor sheathing, and that should make a nice transfer here. And in this example here, we are going to be notching a section of the floor sheathing to go around the rafter beams, and then cutting smaller pieces here to fit in between each rafter. And you're probably going to need to nail the floor with 16D nails and make sure that the floor sheathing has at least a 4-foot break in between the joints or breaks of the sheathing. And you could always do 2 boards at a time. I chose not to do that here, but I will provide you with an example of that with the roof sheathing. And of course, a nice floor finish here around the rafter beams. And I would recommend leaving at least a 1/16 of an inch gap between the rafter beam and the floor sheathing right here. And let's go ahead and remove some of the sheathing here to provide you with an example of why we actually installed the blocks. Now, next up, you could either install the walls or the ridge beam along with the rafter blocking, or you could install the rafter blocking and the collar ties, and then use the collar ties for scaffolding. You can put some boards on top of the collar ties to assemble all of the ridge components instead of working off of a long ladder, if that makes sense. Let's go ahead and zoom in. We are going to have a beam here, blocking here. You might need 2 boards here if you can't find something tall enough. For example, if I need a 2x16 and the biggest board I can find in my town is a 2x10, then I'm going to have a block sitting on top of another block here, or use a taller ridge beam. Let's go ahead and remove the block to give you an idea of how the rafters are going to sit on top of the beam. And you don't need to use this beam. You can have the rafters connect to each other and then install blocks here, as long as you have the collar ties or the rafter ties to keep everything from spreading apart. Next up, we can install the walls, or we can install the roof sheathing. But I would suggest installing the walls if you're going to have a difficult time fastening the studs to the top plates. But again, that will be a decision I will leave up to you. And the wall framing could always go all the way up to the bottom of the roof sheathing, or the bottom plate could be even with the bottom of the roof rafter. Or you could install the wall framing underneath the roof beam. And if you need more information about that, let us know in the comment area. Next up, let's go ahead and install the collar ties. And again, I would like to bolt the collar ties to the roof rafters. And before we install our fascia board, let's go ahead and take a look at the front and the back of the building here. Back of the building. And then take another look at the upper roof framing here, just to provide you with another view that I might not have provided you with earlier on. And another method you might be able to use to install a post in the middle would be to add another collar tie, and then add a block to the center, something like this, where we can have a post fully supported by basically a double joist. And depending upon what your engineer says, you might not need a structural beam. And something like this will work just fine. Also, keep in mind that I'm not providing you with a lot of building hardware in this video. And if you need more information on that, feel free to let us know in the comment area. And at this end here, I went ahead and just simply installed the post on top of the same sized header I used in the previous example. However, you might consider installing a larger header and maybe even double trimmers underneath that header. Again, this will depend upon whether or not this is going to be considered a structural load-bearing beam, or as I'm using it in this video, as a decorative beam, something to make the top of the ceiling look a little nicer. And while editing the video, I realized that I said this board here, the one that's going to be used to position the rafters on the other side. When I said you could attach it to the other side, I meant this side over here. I did not mean the underside or the other side of the roof rafter. And you could always install more than one brace at different levels, especially when dealing with longer roof rafters. And this is what I meant by the double board spacing for the roof sheathing. We're going to have 2 boards on the same break, and then another 2 boards, and then another 2 boards. And you could use this method here for the floor sheathing. Probably not going to have a problem with it. And another example here of how you could finish off the ridge with the sheathing, depending upon whether or not the roofer is going to accept it or not. And we're going to add a spacer between the back of the fascia board and the front of the building. This will allow us to install siding or stucco underneath the fascia board. And for those of you who have been watching my videos for a long time, you've seen that plenty of times in previous videos. Next up, let's go ahead and install the fascia board, and that's going to look something like this. And if you wanted to install fascia board on the bottom, you would just simply reshape the bottom of the roof rafters to where it would be similar to the installation in the previous video. And for those of you who have made it to the end of the video, feel free to leave any comments, questions, or details about specific information you might need to build something like this, something I might not have provided you with in the video, or something I might need to spend a little more time on.